Hello, grade 7. Today, inshallah, we are going to start with chapter 3, which is talking about rational numbers. First, we have to know what is the rational numbers. So we will start the story from the beginning. From the beginning, we have the set of natural numbers, or we can donate it by counting numbers. Then natural numbers, we can donate it by natural counting numbers. In case if we want to count, so we have to start from 1, 2, 3, 4, 5. Could we start with 0 if you want to count your fingers? Then you can say 0, 1, 2, 3, 4, or you have to start from 1. Exactly, we have to start from 1. For this reason, we said that natural counting numbers, which is 1, 2, 3, 4. After that, this set of numbers, if we don't have anyone in the room, and I will ask you how many students in this room. So your answer for sure, it will be what? It will be 0. Could I put 0 in this natural numbers or set of natural numbers? No, because we said that this one is called what? It's called counting numbers. Then we will use 1, 2, 3, 4 for counting only. For this reason, we are looking for another set of numbers which is called whole numbers. And whole numbers, we are going to add to the counting, natural counting numbers, we are going to add 0. So in this one, it will be 0, 1, 2, 3, and so on. We need to extend. We want to expand. We want to increase the set of numbers. So we started with natural counting, and after that, we added 0 to the counting natural numbers to become whole numbers. And then we are going to add integers. So what integers represent? We have already 0, 1, 2, 3. So think with me. You have to extend in the left side, like someone gain weight and the other one lose weight. So they have the same value? No. Gain weight means positive, increase. Lose weight means negative, decrease. For this reason, we are going to expand the set of numbers to make a new set of numbers called integers, which is whole numbers and their opposite. And you know that the opposite of 1 is -1. The opposite of 2 is -2. Opposite of 3 is -3. El 0 doesn't have opposite because nothing called -0. So if you want to describe the integer numbers, it will be whole numbers and their opposite. So you can note here that the basic was natural counting numbers, and then when we added 0, it becomes whole numbers. When we added the whole numbers and their opposites, this is called integers. So any number belong to the natural counting, it will be in whole, and any number in whole, it will belong to the integers numbers. So how we will describe by numbers, you have 0 and the right side 1, 2, 3, 4, and so on. We don't have int. For the left side, you have -1, -2, and -3, and so on. In this case, let me ask you a question. If I have a number like 3/4, so where we have to fit this number, If I will go and ask natural counting, this number, they will accept 3 over 4. If you will ask counting numbers, they will accept 3 over 4. No, I don't think so. Then we will go to the whole numbers. Could you please accept 3 over 4? No, it's a fraction, so we can't accept it. Let's go to integer numbers. Could you please, we can put 3 over 4 belong to your set of numbers? They are going to say no. So what's the fraction needs? The fraction needs what? The fraction needs a new set of numbers. So we are going to make a new set of numbers. It's called rational numbers. If you look at the first part of the word rational, it's donated for ratio, because if I'm going to write the number 3, sorry, if I'm going to write the number 3 out of 4 or 3 over 4, also I can write the same fraction like this: 3, 2, 4. And we studied before, this one is a ratio. So the fraction, we can write it in a ratio form. For this reason, we can remember that rational comes from the word ratio. Then negative 0.76. If this one belongs to the ratio, let me check with you. Negative 0.76, I can write it in a fractional form. Then it's negative 0.76. I can write this in a fractional form. Do you remember how? How many decimal point here? Or the decimal point after how many digits? After 2 digits. Then I can write negative 76 over 100. Yes, in this case, already we change the decimal numbers to becomes fraction. For this reason, it will belong to the rational number. Second question, negative 6 over 13. Then negative 6 over 13, already it's a fraction, so it will belong to directly rational number. Let's move to the next question, 0.08. How we are going to represent this one in a fractional form? We can or not? Yes, we can. So it will be 8 over 100. And after that, we have to put it in simplest form. Then 8 and 100, both of them, we can divide it by 4. Then it will be 2 out of 25. If you will divide this one by 4 to put it in simplest form. Which means by the end, 0.08 belong to the rational number? Yes, it belongs to the rational number. Why? Because already we can write it in the form of A over B, or in a fractional form. Let's move to the last example. 2 out of 3, or 2 over 3. This one belong to the rational number? Yes, because it's written in a fractional form. Let me give you a question, my dear student. If I have a number like 5 over 0, if this number belongs to the rational, it's written already in a fractional form. But Try to think about the answer. This one, it will belong to the rational number? Yes. It's impossible to belong to the rational number. Why? Because the denominator equals 0 and any number divided by 0 is remember with me the word undefined. Undefined. Okay? Have no meaning. Undefined. Which means rational number, it is a number which is written in a ratio or in a fractional form, but we have a condition that the denominator, it's impossible to be equal 0. So I can write it like a form a over b. So a represents the numerator, b represent the denominator, and a and b should be belong to the integer numbers, and it'll be not equal 0, because as I said, if it's equal 0, which means it has no meaning, math error, undefined, so we will not accept. Okay? Also, we can donate the integer like the letter z, so we can say instead of the word integer, so we have the letter z, and for the rational number we can use q. Okay? For this reason, I can ask you a question. If I'll give you a question like 5 over 3, this number belong to which set of numbers here? If I want to classify 5 over 3, this number, it will belong to, yes, it will belong to rational number. So we can say it's belong to rational number. Okay? If I have another question like 15 over 5. 15 over 5. Could you please try to think where we can classify 15 over 5? In each set, in which set of numbers here? 15 over 5, if you will simplify, it will be equal how many? It will be equal 3. So I can say that 15 over 3, it will belong to natural counting. Also, we can say that it's belong to whole numbers. Also, we can say it's belong to integers and belong to rational numbers. So 15 over 5 belong to natural counting numbers, whole numbers, integer numbers, and rational. So it's not necessary to belong to only one set, but it could be belong to more than one set in case if the numerator divisible by the denominator, yes, we will say that it's rational number, but it could be belong to different set of numbers. This is when we have the numerator divisible by the denominator. What else? If I will say that I have negative 8. Negative 8 belong to which set of numbers? Could I say that negative 8 belongs to natural? For sure not, because natural should be positive number. It could be belong to whole numbers. No, it's not whole numbers, because whole numbers, they will not accept negative numbers. Yes, we can say that it's belong to integer numbers. It could be belong to rational. Think, it could be belong to rational. Yes, it can. Why or how? because I can write this one, negative 8, I can write it in the form negative 8 over 1. Then in this case, we already satisfy the conditions of the rational, which means it will be in a fractional form. The numerator belongs to z, the denominator belongs to z, and doesn't equal 0. So we can say something important here. We said that when we classify, so negative 8, it will belong to, as I said, integer and rational number. So we can say all integers, all whole numbers, all natural numbers can belong to the rational in case if we are going to put the denominator equal 1. But not all the rational numbers belong to the integers or whole or natural. Let me show you how. In case if I have 12 over 2, 12 over 2 belong to rational, right? And also belong to integer. Why? Because 12 divisible by 2. Then the integer, the rational, change into integer because the numerator can divisible by the denominator. So this is the first case. So the numerator can divisible by denominator, then rational, sorry, this one is Q, is not R. Then rational number can be integer. So rational can be integer. So this is the first case. If the numerator divisible by the denominator, then the rational can be integer. The second case, please tell me if the rational number can be integer. 15 over 6. How we will classify? So this one is rational, but it's not belong to integer. Why? Because 15 over 6, it's a fraction, and 15 is not divisible by 6. For this reason, it's a rational, but it's not belong to integer. We said if it was 15 over 5, yes, in this case, it's a rational and it's belong to integer. So this was introduction about what is the set of rational numbers, and we started already with natural and natural counting numbers and whole numbers, integers and rational numbers. Thank you. See you in the next video, inshallah.